Hello, AP statisticians, here with the third lesson of the T procedures unit. This is two sample T intervals. Following up, now you've seen one and two sample Z proportion procedures and intervals, intervals and tests, I should say, and you've seen one sample T intervals. So this follows along with all of those. And the last little section here with the T interval and then T test will be lesson 4. What to know here, understanding the similarities and differences between a one sample and a two sample T interval. What makes something match pairs versus two sample? This is something that can give students fits that match pairs versus two sample. And then lastly, how to connect an interval to a test. And so we'll jump right into it here. Really with the two sample, kind of the new thing to be considering is that we do have two unique independent populations that we're talking about. And so that's a key piece here for when you're determining match pairs versus a two sample is, do the two sets of values have a one-to-one connection or not? For instance, a one-to-one connection would be like a pre-test, post-test score for the same person, husband versus wife, siblings versus each other, one person testing Coke and Pepsi and you're comparing to yourself, versus the independent would be like you have this group of 12th graders and then this separate group of 11th graders. Okay, you have this group of people who happen to be husbands and this group of people who happen to be wives, but they aren't necessarily couples together. Um, and it goes on and on with independent populations, these Minnetonka students versus these Wayzata students and so on. The new conditions, instead of one SRS, we now have two SRSs because we need an SRS from each of the two populations, and we need normality out of each one, in that normal sampling distribution. And then this independence between. The independence between is important because that is what tells us that these two groups are not matched pairs. They are two independent, unique samples coming from unique populations. So as we look at an example here, we've got the same researcher who is looking at social media habits is also interested. This is from the one sample part as well. But now we're looking at the difference between senior and junior usage. So here's that two groups coming into play. So to estimate this difference, the researcher collected independent random samples of seniors and juniors and obtained the following information. Using the information below, estimate the difference in means. Okay, so what you're looking at here is you've got N sub 1, or you could say N sub 12 for seniors is 40. The X bar for the seniors is 88 minutes right here. Okay, the S for the seniors, and again, it's an S, not a sigma, because this is a standard deviation from the sample. Okay, if this said all seniors, then that would be a sigma or a standard deviation from a population if our population here was MHS seniors. But it's just the sample. And then we have the N11 group, which is 40. The X bar sub 11 is 97 minutes. And the S sub 11 here is 26 minutes. And it's probably approximately 26 and approximately 31, but we'll just set them equal to it for now. So this is what we're looking at in terms of the data, both the sample size, mean, and standard deviations for both groups. Okay, so this is what we're going to carry forward. So again, we have that first kind of optional step, which is the parameter of interest. And I do want to note what that parameter of interest will look like here, and we'll get into that in a moment, but you do need to be careful. We are looking for a difference in means, which is different than looking for the mean difference, which is what a matched pairs does. So mean difference would be like the average difference in a pretest versus a post-test. Here we say difference in means, and of course that S is very important here because it's talking about how we have two means, two different groups, where it's not one mean of all of the differences. Everybody's post-test minus pre-test, and that difference is what we're finding the average of. In this case, we're finding the mean of the 11th graders and the mean of the 12th graders, and we're trying to find the difference between them. Okay, this is a two sample T interval. And again, we have our big three conditions that we're going to verify. So this would really be the first point if you were to get a two sample T interval question on, say, an AP exam. Okay, so in writing this, I'm going to write up here, we are estimating the difference in means, again, not mean difference, but difference in mean, and I'm actually going to take that plural and put it on the context here, the difference in mean social media usage. Actually, I'm not going to put an S there, but you can understand that it's, again, difference in the two means, social media usage for seniors versus juniors at MHS. And then I'm going to put in here, usually I pick the bigger X bar to put first, just because it keeps that subtraction positive then. But we'll take seniors minus juniors here just because that's kind of the order of the grades. And so, which is just fine. You could do it, you could go juniors minus seniors here, and that'd be just fine. It's just you have to lay out which direction you're going. So this part here is very important, okay? This part right here is telling the reader who's going to go first in your actual formula. And that is something that is important to know because you want to know, really, are we talking about seniors being more than juniors or seniors being less than juniors here? And if you don't notate which one goes first, then you have to make it clear somewhere else, like in writing with your X bar sub seniors and X bar sub juniors, you need to make it clear that who went first there. So you can't just have the reader assume to know which group went first. So just be mindful of that, okay? This is, again, a 2-sample T interval that we're going to be working on. And in terms of conditions, okay, one is that we have 2 simple random samples. Be careful, you do have to remember that it's 2 now, okay, 2 simple random samples. And the question states that it is a random, and I'm just going to abbreviate here, a random sample of seniors and a random sample of juniors. Okay, so again, for a random sample condition, you're basically always just referring back to the question with some level of specificity to make sure that it's clear to the reader that you know where in the question it refers to it. Don't just say stated or stated in question. You'll see some of my answer keys every once in a while have that. That was me being lazy and setting a bad example. 2, normality for both. And what we have here is, if you recall, n sub 12 equaled 40 and n sub 11 equaled 40. Obviously, those are both greater than 30. So both sample sizes large enough to utilize the central limit theorem for a normal sampling distribution. Okay, and again, that's why that sample size is important, is we're trying to get to that normal sampling distribution. Okay, the third condition, the big one here, is the independence between. Okay, independence between just is stating that there's no reason to believe the two groups would impact each other or would have an influence on each other. So on this one, you don't need to get, there's no technical way here. It's just really kind of recognizing that you know that's important. So I'm just going to say fair to believe the two populations, or samples you could say, two populations are independent of each other. Okay. And that's all you really need to say for that one. You can always just kind of state that it's fair to believe that. And if it's not fair to believe that, that means it wouldn't have been a 2-sample. It would have been a match pairs or something of that nature, or neither, and it was just something goofy. The last one, you could have the 10n is less than capital N for both, like we talked about a little bit with the previous lessons. That's, again, independence within each group, basically saying that I didn't pick a bunch of seniors who hang out with each other and a bunch of juniors who hang out with each other. So you can see the difference here. This is about, the third condition is about between the two groups, juniors to seniors, and number 4 is really about having independence within each group, meaning the seniors aren't all knowing each other or impacting each other, and then separately the juniors aren't all knowing and impacting each other. But right now we're really focused on these first three conditions here. Okay, moving into the actual meat of this now. So step three is the test mechanics. So one and two, one was the parameter of interest, which is that we're estimating the difference in social media usage. Two is the type and conditions. And then step three is the actual mechanics. And you can see here is our formula that we're going to use. As you recall, I'm going to make my seniors group one because I said the seniors would go first. And I'm going to make the juniors group two. Again, that could flip-flop. And what I mean by group is these subscripts. That could flip-flop if we wanted to. We would have just had to have said juniors minus seniors instead of seniors minus juniors. Okay, and again, I typically put the bigger X bar first, but it's okay if you just again went with seniors first because they're the older group here. So what I am going to do now is I'm going to take my values and put them into this formula, and then we'll talk a little bit about TR. So what I'm doing with this is I'm taking my seniors first. So I have 88 is the X bar 1 minus X bar 2, which is my juniors, excuse me, my juniors X bar, which is 97. Okay. Now, if you recall, the next value here was T star. T star is a value that is actually comes from a chart. It's how many standard deviations. We're going to go in either direction, and it's based on our confidence level. So if we typically go 95% confidence, then we can get roughly in the area of a T star. Now, what happens with a 2 sample is the degrees of freedom. The conservative is actually the smaller n minus 1. So the conservative degrees of freedom number here would be 39. However, when we go through these calculator steps, we are going to get a different T star as long as you use your calculator, because your calculator gets a different degree of freedom value, as you can see right there. So actually what I would recommend is anytime you have a 2 sample T interval, always just write T star. Do not put any value right here. Just leave that as a T star. That's just fine. In fact, you don't have to write any of these values except for the final answer if you have already noted that this is a 2 sample T interval. So once again, I'll say that this formula that I'm writing here, which is now the S squared over N for each one of these. So that would be 31 squared over its N plus 26 squared over its N, which again, if back to the formula, this was S sub 1 squared over N1 plus S sub 2 squared over N2 from the last slide there. So this is plus or minus T star. So this was the whole formula. Sorry, it's kind of ugly there. But when we write that formula in, we can actually avoid writing that completely if we've noted that this is a 2 sample T interval, okay? Or we've written the formula generically like I did inside that circle there. So you don't ever actually have to write this formula with the values. If you're really comfortable and confident to do so, I would do it. But if you don't, that means you have to have already noted that this is a 2 sample T interval, okay? Now, you can see from the calculator steps up here, okay? So when I go into my calculator to stat tests, okay, stat tests, I go down to this 2 sample T interval here, okay? Stat test, 2 sample T interval. I'm going to put in stats because you were given stats in the question, which means you're just going to be typing in these values rather than giving just a list of numbers. Now you can see the values I have in there in my calculator are not the ones from this problem, okay? So I'm going to actually type the ones in from this problem on my own right now, okay? And so my X bar 1 is 88, my S1 is 31, and my sample size is 40. My X bar 2 is 97, my S sub X2 is 26, and my sample size for the second one is 40, and I'm going to go with a 95% confidence interval. You will never ever pool, so just leave that as a no. We can talk more about pooling in class. And so I calculate. Now, when I calculate this, my calculator returns this, an interval from negative 21.74 to 3.74 with 75.71 degrees of freedom. This is all I'm going to write. So those are the top two rows you can see in what your calculator outputs, again with different numbers here. So this right here is my final answer for step 3. It's okay to write just that as long as we've already said this is a 2-sample t interval. Okay. Now, as we look at this interval, we have to think about what this means. Okay, the negative 21.74 means that it's fair to believe within our 95% confidence interval that seniors spend about 21 to 22 minutes less per day on social media, but the top end of the interval is a positive 3.74, so seniors may spend between 3 or 4 more minutes on social media. Again, that's just the nature of the confidence interval. Our margin of error is pretty big here. Okay, our margin of error is about 10.74 in both directions. Okay, because 88 minus 97, actually 12.74 in either direction here, because we've got a negative 9 was our middle of this interval. Okay, so what that did here then is that interval, since negative 9 was in the middle, so this was negative 9 plus or minus about 12.74 is what the margin of error was. And that interval then got us pretty big into the negatives, but also possibly into the positives. So we're 95% confident that seniors spend somewhere between about 21 minutes less to about 4 minutes more, 22 minutes less to about 4 minutes more on social media per day. Well, what's really important to note here is that the number 0 is in our interval. Since the number 0 is in our interval, that means with our 95% confidence and our 95% confidence interval containing 0, that we have evidence that there's not a statistically significant difference in the amount of time spent on social media between seniors and juniors. So even though our sample returned a lower X bar for the seniors, statistically speaking, we're saying there is no difference here. And that is, again, because 0 is in our 95% confidence interval. And that's terminology that's straight from the AP exam. So saying that because 0 is in our 95% confidence interval, and again, issuing that confidence level again, we do not have statistically significant evidence of a difference between the seniors and juniors in their social media usage. So as to writing this in a conclusion, okay, sorry, I put my mechanics already there. What we are going to say is something like this here. Okay, we are 95% confident that our interval from negative 21.74 to 3.74 contains the difference in mean against social media usage between seniors and juniors. Okay, and if 0 is in the 95% confidence interval, then there's not a significant difference between the two, which we've just stated. So, so the long-winded approach again is we are 95% confident that our interval, which runs from negative 21.74 to 3.74, contains the, again, not mean difference, but difference in mean social media usage between seniors and juniors. And again, I'll just note again that this was 12th minus 11th, just because I can here and it's quick, at MHS. And then again, I could follow it up by saying, because 0 is, and you don't have to answer this all the time. They'll ask this question in part B a lot of times with intervals about that 0. So because 0 is in our 95% confidence interval, we do not have evidence of a statistically significant difference between the seniors and juniors in terms of social media usage per day. So this again is a 2-sample t-interval and what it can answer for us. Okay, again, this is our main interpretation, the top one in red there. The bottom one is if they were to ask the follow-up question of, based on our interval, is there evidence of a statistically significant difference? Okay, and so that's what the black notation down at the bottom represents. But as always, thanks for watching and listening. And if you have questions, please make sure to ask.